What's up, everybody? Welcome back to Make It and Break It. My name's Andrew, and today we're going to do our last big push to get our Project HyperTenere mostly ready to go. So what do we have majorly left over? Well, last time we were on this thing doing some major work, we were trying to fix the foot controls, foot peg mounts, and everything so that they're all working. We got the right side done, this one over here, which works pretty well. But we didn't get the left side done because we broke a tap inside the piece. Unfortunately, I had those things remade and sent back, and it didn't work out. The way they were made was not conducive to tapping. They were cut out in a way that was not a consistent circle, so that none of my drill bits and the taps really liked it. So we're gonna have to go with the backup method here, which is welding them together. So we're gonna do that today, and then we're also going to finally make our brake levers and shift selector levers so that we can ride this bike, actually work it in a, normal manner. So that's the main stuff we're looking to get done today. Maybe we'll get done some other stuff. We'll see how much time we have, but let's get to it.
So the original idea here with this drill was to drill out the holes that would have been threaded and put some rods in there to fill the holes and give us a little bit more structural stability. After messing around with a moving table a little bit, some stuff went wrong. So after having a bit of a laugh over another broken drill bit, I went on to the welding portion. So we're removing scale and the plasma marks from the exterior of all of these pieces. At least the pieces are going to get hit with weld metal, so we have a cleaner surface. And then we moved on to beveling. I wanted to take a quick minute to discuss why beveling is a really good idea in this case. So in this figure, we have a plate setup where we're welding two plates together. That's the white squares. On the left hand side, you can see the weld setup. There's no prep or anything on this edge. They're just straight edges, pretty much right as they would come off a plasma cutter or just off a piece of plate. And on the right hand side, what you see is that little orange section is the actual weld bead. And you can see on a piece of plate like this, if you welded them without any preps or bevels on the edges, what you get is a weld bead that's very high and proud over top of the plate, but doesn't get much penetration, which is the amount of weld metal, the amount of orange that's below the surface of the white plates here. And that penetration is what's really going to give your weld the strength and durability long term, rather than just looking nice up on top with a bunch of proud extra metal. So this second figure shows an end-prepped plate weld with the same setup, the only difference being we added a couple bevels to each side of the weld joint here. And what you're seeing is the bevel allows more weld metal to fall into the joint rather than staying on top of the plate and not adding any strength to the joint. If you set up your bevel properly, what this would do on a joint setup like this is allow the entire root gap, or that space between the two pieces of plate here, to be filled up with the orange weld metal. So you would essentially have white, orange, white with no light blue gap of air in between. This is the strongest way to make a welded joint. On thicker pieces of weld metal, where you can't access the back side, you might just settle for a partial penetration weld, which is what's shown here, where you still have some small amount of root gap remaining on the back side that you can't access, but your weld design takes that into account. But we're not going to get into weld design and weld terminology here. This is just a quick primer on why you should bevel your joints. This beveling philosophy works on every type of welded joint, basically. So if you're welding roll cages or crash bars or plates or sheet metal or anything like that, sheet metal, you typically don't need that because the metal is thin enough that the weld metal can penetrate all the way through. But any thicker weld, structural weld metal, beveling or prepping, end prepping these the joint connection will drastically increase your weld strength and quality. And now, back to the montage. Now, if you can't tell by the expression on my face here, I am not happy with this result. I actually ended up having to stop welding, go ahead and cut off and re-prep a lot of these pieces because the first slug had actually lifted during initial welding. But I fixed that with a bunch more clamping this time around. Okay, so we actually managed to finish this fabrication here. I did want to admit to a couple mistakes to you guys. One is a kind of cardinal sin of fabrication. Don't permanently affix everything until you're sure everything's going to fit the way you want to. I didn't necessarily do that here. So unfortunately, and you can see how kind of ugly this turned out. It probably was going to turn out this ugly anyway, but I did it in the wrong order. I don't think it really affected things too much, but I did want to go over it for you guys, just so you don't make this mistake when you're doing projects like this. How you're supposed to assemble this thing. So this is our main piece here, plus a slug that's kind of under this weld nest here, plus this piece, which was what mounts the ears, and then our foot peg, right? And so all of these pieces are welded onto each other in kind of a stack coming out. The way you're supposed to fabricate this is you're supposed to tack this weld, and these ones all down. Just tack them down, but don't permanently weld them in case you have to adjust them, like I actually had to do on this top one here because it was starting to lift. But once you get them all tacked down, then you put it on the bike like this, put this thing on, and make sure you like it. That would stop you from having the one little issue I have right now. If you kind of look at this thing, maybe it's hard to tell on the camera. I feel like this foot peg is canted like a degree or two forward, like this way. I don't think it's going to make too much of a difference, especially since these are pivot pegs, right? So these rotate 15-ish degrees either way. So it's probably going to be fine when you're riding it, but it does bug me looking at it. And if I had fixed that, I think I caused that just from some of my initial welding here, and just the fact that it's really hard to align everything. Once you have all of this big proud weld up here, now aligning this to an edge that's kind of underneath a weld is very hard. So I wanted to just run over that for you guys real quick. But now it's time to move on to pedals. So where's the other broken part of this one? Oh, it's up here. Okay, so this is the clutch side. So this is going to be our gear selector lever. This was kind of our 3D printed mock-up. This is what I thought we would like. And honestly, I put my boot up here and it's pretty close, except for, I don't think this will stay on anymore. I've dropped it off a few times. Except this front piece, I think I want it to move this way like another inch or so. I was doing that because I was actually looking at the DRZ out there. I was looking at that pedal out there, and that one's quite a bit farther out from the center line than this one is. So I wanted to give ourselves a little bit more room to shift, get our toe under the shifter lever and everything else. So I think I'm going to add about an inch to this length, basically an inch from this center line length to the center line of the toe pedal. And then luckily, because of all the adjustability in here, we can rotate this around to kind of whatever height we feel like we need. And then this is going to be kind of based pretty much on this. Going to build something like that and just have a little round tube with something to bolt into or a stud sticking out of it or something like that. So we're gonna build this using these basic materials. So the idea here is that we're gonna make pedals that look like this. This is the clutch side lever again. The brake side lever looks fairly similar, except it has one of these pedals on it, which kind of bolts in on both sides, as well as has to attach to the master cylinder, so this end will look like a little bit different, but the function is pretty much the same. You have a center barrel and two arms coming off of it on either side. So to do that, we're going to use this piece of steel rod to kind of make our center barrel. So this is 1-inch steel rod that we're going to go drill this hole through so it will clear our shoulder bolts that are in there. And then using these pieces, we're going to make these other sorts of sides here and here. So this long piece here is going to be probably both sides of this piece. Oh, just broke it. Both the piece that goes back down to the actuator that runs actually into the transmission, as well as the pedal side. Whereas on the brake side, this actually is a little bit too big to fit over this, and this width needs to be a little bit thicker. So we've got this big piece that will cut down the size for this pedal side and probably still use something like this size for the brake side, brake master cylinder side. So first thing we've got to do is figure out how much of this we need to cut out and throw it on our bandsaw, I hope, and cut this baby down to size. Okay, we're jumping ahead a lot here, and we've got both of our pedals kind of mocked up in place. This is the correct way to mock up your pedal, by the way, or mock up your fabrication. Notice I have a single tack pretty much in each one of these positions here holding things in, except for this pedal. This pedal comes right off. I haven't drilled the holes for that thing yet. I wanted to finish the pedal mat fabrication, and I like kind of where it sits. If you kind of look down here, there's a little bit of a tilt going forward, which might change a little bit as we adjust this if we extend this out and lift that up. But overall, that's not a bad setup, I don't think. I think we'll have an easy time putting our feet on the brakes when we need to, whether we're standing or sitting on the bike. Note here, we tried out two different fabrication techniques for these levers. This first one, I cut out sections of the bar, cut out sections of the bar into this shape here. So we're actually going to be welding both sides on all these sections for mostly full penetration welds, except for this one. This one will be a partial penetration weld, but I don't think that will matter as much on this weld. On all of these. And then on the other side, we have our actual clutch actuation, our gear selector lever here. This one's much the same way. Notice I have single tacks. This one took me a couple tries because I kept breaking it. Because I get so excited to try and use this and then I break the tack because tacks aren't all that strong. But these are heavier tacks. This one, hopefully that didn't screw up the audio, I bent into place from a single piece of bar. So I put this on the bandsaw in this case and cut that and then just bent things into place where I need to. And then what we're going to do is going to go back into these joints here and fill them up with weld. Although, in this case, we're probably going to do 2 layers of weld. These are 1/4 inch thick pieces of bar here. And my welder is really only hooked up over there to 120 volt. Like just standard power from the outlet. So that really puts its maximum thickness at about 1/8 of an inch in terms of what it can weld in a single pass.
So what we're actually probably going to do is open up these a little bit and put a couple layers of weld in here just to fill up this area and bring some of our strength back to this piece of metal. But you can see everything's tacked in here. This is that little...
Joey's scared. He wants to see you.
Okay. Hi, Bob. How's it going? Welcome back to the channel.
You can't hunt us. I don't have a bra on.
Oh. Well, we'll probably post that part then. What's going on over here? Yeah?
Joey, you want a treat? Let's go get a treat. Come on. Come on.
I think he wants you to bring him a treat.
Joey, let's go. Come on. Joe. Come on.
What is up, bub? Well, everyone, Joey has decided he wants to hang out here with us today. So, I completely forgot where we were going with this, but you can kind of see how we built this here. So there's this little piece up here. This is threaded and then welded down in here onto this little piece, and then our foot goes in here, and you know, down for shifting down and up for shifting. You can see that's probably a little bit lower than we'll actually ride with it. This is adjusted in its fully lowest position. Everything else from here on out, we just spin, we'll raise it into a more comfortable riding position. So that seemed like the smartest way to set this. Our brake side is set more in the middle, so I think it's pretty close to what we'd actually ride with right now. But we're gonna you know, have to mess with that, and hopefully not have to mess too much with that. But anyway, the plan now is pull these back off, get everything fully welded up, and then we can test them out. So I'll catch you guys at that point. Joey, you gonna be here too? Okay, and if you look at this, we have a complete lever set, actually. So this is the gear selector lever. It's at its most down. Obviously this can raise it quite a bit, so we'll have to play with that, but that is as low as it goes anyway. Pretty happy with the results. The welding is not amazing. Let's see if we can get in a close look at some of this stuff here. Welding's not amazing, but it's not horrific either. I mean, this stuff kind of looks goobery, but a lot of these welds are these multi-layered welds. This was the bent piece, so I had to fill in basically a deep V of weld metal. Went pretty well, and I'm pretty happy with the results. And it certainly seems stable enough. It's shaking the whole bike right now. So everything seems to be looking pretty good. We'll have to do a little bit of cleanup with the grinder here before we go do the finished painting of everything, but I'm not the most worried about that. So this is looking really good right now. And well, I'll also have to adjust this so it faces the right way. But yeah, foot control's done. This is your left side, and this is your right with better lighting because I left the light over here. I was too lazy. It's late. I wanted to get this video done and get all this work done. And you can see the difference here in fabrication. These are just big old double-sided butt welds. They also seem fairly stable. I don't have the pin in this, so it doesn't actuate the brakes like it's supposed to. Also, I need to clean up the back side a little bit, but that's all cleanup we'll do right before we paint, so I'm not super worried about doing it right now. But we have foot controls, which basically means our bike is ready to ride. Well, except for up there we need to solve our wiring issues, but that's a different video. Anyway, it's late and I gotta get this stuff on the computer and finally get a video out to you guys. So we're gonna cut it there. Thanks for watching, guys. I think this is gonna end up being a little bit shorter. We're gonna try out a shorter format and not a 37-minute video with a bunch of time lapses. So we'll see how that goes. Thanks for watching, guys. My name's Andrew. This is another Make and Break It YouTube video channel. YouTube video channel. Ooh, we're really screwing up this outro. Another Make It and Break It YouTube channel video. Like, comment, subscribe, all the YouTube things. We got HyperTenere, and we are gonna pick up our Project Doritos Locos RX-8 here very soon, because this thing now no longer requires all of this garage space in order to get it done. So, thanks for watching, guys, and I'll catch you later.